Okay, so now moving on to pie charts and Venn diagrams. The pie chart and Venn diagram below show the proportion of students at local secondary school who are enrolled in specific subjects. My total student number is 14,943. So how many students are enrolled to study IT? Right, the way that we do this is by knowing that, okay, this is your routine circle, right? All angles in this circle will add up to 360 degrees. So if I do 4 right angles, okay, that's 4 times 90 degrees, so it'll add up to 360 degrees. Now, what this means is if 60 degrees is part of a circle which is 360 degrees, we can work out what fraction it is of the total students. So what I would do is I would do 60 divided by 360 equals, and I'll do that in the calculator here. So 60 degrees divided by 360 degrees is 0.166 or 1/6. So this means that 60 degrees is 1/6 of the circle. Now we know that a circle just represents 14,943 students. So we times this number here, which is a sixth, as we just did, times that by the total student number, 14,943. That would give us 2,490.5, which we'd round up 2,491. Now next one, what percentage of the total student body are enrolled to study English? Okay, so the way we can do this is we can convert the fraction that we just worked out here into a percentage. So a quick way to do this is to get 360 and take away all the ones we already know to get x. So we take away 60, take away 85, take away 45, take away 45 again, 60 again, and 65 degrees for English. We divide that by 360, and that will give us the percentage, which is 18%. I'll times it by 100 just to make sure. Okay, 18.05%. Now, the 5 is in the second digit, so we had to round down, so that'll become 18% of the total student body enrolled to study English. Okay, now next. If the minimum percentage of either sex enrolled in each subject is 40%, what is the maximum possible number of males enrolled in all of the subjects? Okay, this one's kind of tricky, to be honest. Maximum possible number of males. Okay, so what this means is there must be at least 40% females or 40% males on any subject. So if we're going for maximum possible males, we do 100, take away 40, because there must be 40% females. That'll give us a maximum of 60% males. So the maximum possible number of males enrolled in all the subjects. Now, maximum males 60%. Take that away from, times that by the total student number. So we multiply that by 14,943. Oh, sorry, I forgot to turn it into decimal. 0.6, because we just divided by 100, times by 14,943. Gives us 8,965.8. Now I just round that to 8,966. I think that's right. That one's kind of tricky, to be honest. How many different groups of students are enrolled in only 2 subjects? Alright, what we have to do here is we have to look at the Venn diagram and we have to look at the overlaps. Basically, if there's an overlap like between English and history, it's only an overlap between 2 subjects, which is what they're looking for. So let's count. That's 1 between English and history, 1 between history and maths, so that's 2. History and science, that's 3. Science and IT, that's 4. IT and technology, that's 5. Technology and maths, that's 6. So we've got 6 there. Now let's mark the test. We'll see what we get. Oh really? Did I miscount? I'll count this again because I might have made a mistake. Well, I did make a mistake. Ah yeah, I forgot to count these ones in the middle. Maths and science and science and technology. But that's the only mistake we've made. We've got all our pie chart ones right. Oh well. Okay, so just a little bit more on pie charts. Fruit stall owner is designing a pie chart to show the proportions of each type of fruit he has sold. He's made the pie chart to show each fruit as a percentage of the total fruit sales, but has forgotten to change the values from degrees of the circle to percentages when drawing the chart. So what percentage of a total fruit sales are bananas? Right, so bananas is 32.4 degrees, and if you remember, to convert degrees in a pie chart into a percentage, we get the value of it, so we get 32.4, and we divide it by 360, which is the total number of degrees in the circle. Now this will give us, let's have a look, 32.4 divided by 360, 0.009, that's about 100, that's 9%. So I'll just make a little note of that. Now we'll put it down as our answer. Move on to the next one. The salesman sold 450 pieces of fruit in total. How many pairs were sold? Okay, let's just do the same thing again. Pairs is 57.6 degrees out of 360. So 57.6 divided by 360 is 16%. Now we times that by the total number of pieces of fruit, and that will give us how many pairs were sold. So 16% of the fruit were pairs. 0.16 times 450, 72 pairs were sold. And we on to the next one. 200 pieces of fruit were sold in total. Oranges cost 0.45 each. What was the total cost of the oranges sold? Okay, now let's do the same thing again. Let's work out what percentage of the pieces of fruit sold were oranges. So 118.8 divided by 360, 33%. 33% were oranges. So we times it by 200. There are 66 oranges. Now if oranges cost 45p each, we'll times it by 45p, 29.7. So 29.7 pounds worth of oranges were sold. Okay, assuming 500 pieces of fruit were sold in total, how many more apples were sold than mangoes? Alright, okay. So I'm going to work out the smaller one first, so that's mangoes, which is, actually no, I've got quite a cool way of doing this. So you can work out both of them separately and do it like that, but a quick little life hack for you is to do 86.4, so the number of degrees of apples, take away 64.8. That gives us the more degrees that apples has over mangoes. Now we convert this into a percentage, dividing it by 360, that's 6%. 6% of 500, 30. That's our little life hack. Basically, instead of just finding out how many numbers there are and then finding a difference that way, we just take away this, we find the difference in degrees between mangoes and apples, convert that into percentage, and then times by 500 to get our 30 pieces of fruit. And that should be it. Let's see how it goes. Aye, easy wins.